Good morning, ladies and gentlemen. Welcome to the energy management session. My name is Ngwanatari Maja, and I'm one of the project managers for the IEE project within the NCPC. Just before we kickstart the session, just a quick announcement. For those of you who didn't get a chance yesterday to see the fan system demo rig we have at the back of next to our exhibition hall, please, during lunchtime, go there and really get a touch and feel of what a fan system looks like and what you need to do for fan system optimization. We have a demo rig at the back for your benefit of you getting some experience on what we talk about with some of these concepts that we present today. Okay, so for this session, we're going to unpack what we really mean by energy management, right? One of the most critical things that make or break any progress that we will make towards climate change mitigation is not only what we implement or what decision we make or action we take, but most importantly, how we sustain those actions and the decisions. So for us to have incremental change over the lifetime of an organization, we need to have a method, a system, a process, a tool that enable us to see those incremental changes so that actions that we take, decisions that we make are not once off, right? Any organization that says they have completed an energy management process, they're done. They don't see the full picture. You can never say, I've completed my energy management process. For as long as the organization exists, energy management has to be a part and parcel of the organization. So you may ask yourself, okay, so if I'm going to make this animal part and parcel of my organization, what do I need to have in place? Somehow you need to have a way of determining for yourself as a business what your North Star is when it comes to energy management. You need to determine for yourself what are you working towards, what targets you want to achieve. What are those things that are going to drive your sustainability journey? Most importantly also, you need to be able to have a mechanism that enables you to pool resources. Because remember, with energy, you also have other competing business needs. So in a world where businesses are competing for resources, not only in terms of money, but also people and time, you need to coordinate your effort on energy management. So an ISO-based 50001 energy management system allows you to create a platform that makes energy management not only something that sits within a plant manager's office or an engineer's office, but it actually takes energy management in the boardroom, in the CEO office. And that's what we need to see for us to have incremental and sustained effort in improving energy performance. Very importantly as well, when you talk about energy management, we need to have a way of determining for ourselves what metric are we going to use to check ourselves if we're making progress. There's a variety of ways that you can check whether you're doing good or bad. But we need to have some consensus on what do we actually define for ourselves as performance improvement. Also very important is we need to be able to, as a business, to ensure that any action that we take, any good action that we take, it could be procuring a new technology or implementing a new process, we need to make sure that we do not diminish those benefits in downstream inefficient practices or processes. So everything needs to be integrated into one, and that's what we're going to share with you today, a methodology, a tool which, if you effectively implement it, you'll be able to not only see once-off changes in your energy performance, but incremental over a long time. Yeah? Very important as well to the dialogue on energy is not only the demand side as well, but the supply. We cannot run away from some of the challenges that we have in terms of quality of energy supply to our facilities. But before we talk about getting alternative sources of energy into our business, we need to be able to be confident in what our actual demand for our facility is. And that's what ties energy efficiency and renewable energy into the big program of energy management. It will be very unwise to just first go into looking at renewable energy solutions before you remove any inefficiencies in your system. So for this session, we're first going to just paint you the picture of what energy management system is all about, what ISO 50001 is all about, and what benefits are there long-term for your business. Then we'll take in a step further to unpack also what energy optimization exists. In the case of our session today, we'll give examples of optimization within thermal energy system, refrigeration and chiller system, which Kevin will take you through. And lastly, we'll conclude the talk with the supply side of energy with talks around PV solar system, how you go about implementing that. Without further ado, I'm going to introduce to you first speaker to stage, Faith Mkachwa. She is one of the project managers for the NCPC Industrial Energy Efficiency Project, and she'll take you through energy management system. Over to you, Faith.
Good morning. Thank you everybody for making this session. I'm a passionate energy efficiency and renewable energy practitioner and specialist, and I love talking about energy efficiency, but particularly this topic, and I'm about to hopefully get you to start thinking about why your organization hasn't considered being ISO 50001 certified. If you haven't, if you're thinking about it, I'm here to give you a way to hold your hand somewhat, because it's going to be a long road, but we're here to assist. And I'm going to share with you some of the short case studies, but you will also note that I didn't go out of my way to include the step-by-step case studies. But if you go to our website, ncpc.co.za, then you can download the shorter version, which are the 2 pages, and of course the longer version of the case studies for individual companies, specifically talking about every intervention we've had. And also you can just specifically decide you want the ISO 50001 case studies. So, my name is Faith, and what qualifies me to speak about this is because I'm a member of the ISO Technical Committee 301, which means I sit with other experts at the South African Bureau of Standards and look at the standards that are applicable, that will benefit South Africa or industry in South Africa as well. So, the first thing that I want to introduce to you is the project itself. Some of you may not be familiar with the IEE project, and there are different or various entities that make it possible through funding, through other support as well. And in that case, we are hosted by the CSIR, and of course supported by the DTI and funded by the Global Environmental Facility through UNIDO. And of course, we also get support from SECO, the Sea Secretariat for Economic Development. So our intervention is not just saying, I want to be ISO 50001 and then voila, we'll make it happen in your absence and you don't have to be involved. You actually do the work, but we make it easy in that we support you fully, we train you, we make sure that we come and support you technically. But also, we do all of those things. We will help you with technical evaluations of your site. If you need any energy systems optimizations, we'll come and do that. And then we will train you or some of the representatives from your company on the subject of energy management systems, Energy Management 101 and energy management performance indicators. But the last step, we also get you ready for that. Unfortunately, that we do not do. So that is a disclaimer. We are not a certification body. So we don't come and certify the companies ourselves, but we will help you to make sure that you are ready for certification. So in other words, everything that has to be in place for you to be certified, we'll make sure that it's there. So I bring a set of fresh eyes. You sit in your plant, you see all the things that are working. I walk in and I see all the mistakes, or the things that are lacking, rather. So that is the benefit of having me or any of my colleagues or our consultants come to your side and assist. And of course, we don't just come the day before, we start with you. So when you enroll for the first Energy Management 101, we are there. That's a day course, and then 2 day, and all the way to expert level training. And we've got various ways of doing it. And of course, every company is unique, the challenges will be unique, and that's what we tackle when we are there with you. So the whole point of looking at ISO 50001 is that we already know and understand the challenges. Some of them could be staff turnover, but the fact that you also want to be certified for other ISO standards like 14001 or the quality management standard 9001. So if you want to do that, ISO 50001 is flexible enough to work with the rest of the ISO 50000, the ISO standards. So this was just to show you what I was talking about with regards to TC301. So every country is represented in the body of ISO through these technical committees. And in my case, I sit on the TC301, which is the energy management standard. So we look at a suite of standards that support energy management. It's not just one standard, but of course, the main one is ISO 50001. And I'll show you the rest of the standards. So South Africa, as you can see, is a participating country or a member of the ISO body. And the one thing I wanted to highlight is that this is done in conjunction with SAB. So we don't directly contact ISO, we do it through SABs. But the most important thing is because as NCPC, we are not industry, but we're not government. And we're also not a certification body, like I said, so we're not SABs. But we feel we are the ideal institution to go to industry and create a conducive environment for a new standard, for a new regulation, for a new policy. So that's why when we say we advocate policy, that's what we're talking about. And similarly to standards, if they are complicated, we unpack them and then we go to industry and show you how to implement them. And once we're done with that, we compile case studies to show you that it works. I mean, we can't say it works and we have no results for it. So those case studies that you will see when you go to our website, it's because we show you that it works and how much it has worked for South African organizations. Because we believe that standards is that oil that lubricates the machinery of our economic growth and also facilitate international trade. You want to be global players. We live in a global village. So you cannot do things in isolation when the rest of the world is turning to the left. We've got to turn to the left as well with them. But also these will give us a competitive advantage. Now we're talking the same language as the rest of the world. Of course, there are things like the other challenges that they're not aware that we're faced with. And we don't know some of the challenges that other organizations in other parts of the world are faced with. So that's what we deal with as at SABS. So like I said, ISO 50001 is the main standard, but then there are other standards that support this. So for you sitting in the organization, the rest of the standards may not support you, but trust me, they've worked for you in some way, because when we send somebody to help you with an energy audit, for example, they follow a particular standard. When we send somebody to come and do your M&V, they follow a particular standard as well. So all these other standards that support the main standard, which is ISO 50001. And you can see most of them start with the 50. The 50,000 is simply because they are the same family of standards that really help to maintain and uphold the main standard, which is ISO 50001. And later on, I'm going to talk about some of these standards and the context. So these are just some of the standards that are currently in development. At a given moment, we are working on more than one standard. So South Africa is raising their hands. South Africa is raising concerns and voicing their views and the problems that industry is facing with implementing some of these standards. And we try and incorporate them, sometimes even changing the standards so that it can work for us as South Africa or South African industry. So in some way or the other, like I said, you may have been involved with, if you're thinking about ISO 50001, or you've just implemented energy management systems, which you will do as per ISO 50001, then the rest of the standards that support 50001 has worked for you in some way or the other, without you voluntarily or feeling like you are doing it. So why would an organization want to worry about ISO 50001? I mean, certification on its own brings about this negative connotation about it. It's a lot of work. They require too many things. But do I really need to comply in order to make a profit? And we agree. Businesses don't exist to save energy. Businesses exist to make profit, to better our economy. But now, I think between today and between this morning and yesterday, you will understand that there is no way in any country at the moment that you will consider economic benefits without considering sustainability. And energy efficiency, or energy in general, is a big driver of economy. So if you say you are only focusing on the economic benefits, but you're not going to focus on the energy efficiency side of things, you're probably fooling yourself, because you cannot focus on that in isolation. We all have to get to a point where we're interested in sustainability. All the presentations and the breakaway sessions speak to that. Yesterday I was in the green chemistry session. It does speak to sustainability. So this is just one of the ways that will make sure that you make your contribution in sustainability as an organization as well. But also, the one thing that's embedded in ISO 50001 is the continual improvement. What we're saying is that it's not enough to save energy today or to do good today. It's got to be a sustainable thing. You've got to have a future perspective. So when you become ISO 50001 today, it is not for life. Energy management systems and ISO 50001 is a performance standard. So it is based on your performance, how much energy you are saving in your company. So the minute you stop improving, the minute you stop being sustainable, you will lose your certification. So there's a process for recertification throughout the value chain of your processes and your product and your manufacturing. So it also consistent with the rest of the ISO 50001 standard. In fact, if you look at the relationship between 14001 and 50001, you will see that 50001 is a performance extension of energy within the environmental aspects that are embedded in 14001. But of course, we can always translate this. Engineers, technical people in the plant, they translate this in kilowatt hours, in gigajoules. You can always translate this into rands and cents, and of course CO2 emissions, so whatever works for you. But also, for most companies these days, because suppliers or OEMs also demand that if you want to continue to be one of our suppliers, you have to become ISO 50001 certified. That means it gives you a competitive edge somewhat. So if you don't know what's happening in Germany and your competition is a company based in Germany, the very least you know that they are going for ISO 50001 certified, or they are already certified. So at least you can do that as well and get on the bandwagon. So now, recently in August 2018, we've had a revision and a finalization of the previous ISO 50001 standard, which is the current one for South Africa. And the reason I'm saying is the current one is because we haven't fully adopted it. The process is nearly done for SABS to formally adopt the current standard, ISO 50001 2018. When I spoke to the chairperson, she promised me that we will have the standard ready by October. But that doesn't mean that we cannot continue to certify. We continue to certify as per ISO 50001 2011, and then there'll be a migration stage where you'll just migrate to the 2018 version, just like we did, those of you who are familiar with 14,000 in 14,000. So the nice thing is that for 2011, we had this thing, and I thought it was fantastic when I first saw it. I thought, wow, you have to create a balance between the technical aspect and the managerial aspect. So that means top management is involved throughout, but 2018 made it even better. They said, you know what, it's not enough that top management is somewhat involved. They have to be in the center and the middle of this thing. It's about top management, it's about leadership. And of course, we changed the term top management because, as you know, the ISO standards get translated into over 26 languages. So direct translation for top management in other countries was just not acceptable. So we call it leadership now. But it actually covers the same thing. So you can see now that leadership is right in the middle, whereas here it was an aspect that we had to balance. So we do what we do and go to top management. We do what we do and then report to top management. We do what we do and then ask top management for support or resources. It doesn't work like that anymore. Now we have top management being in the center of it all. And of course, you've got your planning, you've got your support, operation, performance, and improvement. And that speaks to those continual improvement that I mentioned earlier. And of course, this I took right out of the standard. It still considers both energy performance and management systems approach to manage our energy. The standard addresses explicitly. And for me, I said hallelujah when I saw this, because in our training on energy management system, we've always been talking about this, but it was not very explicit in the standard. So now you have to look at energy performance indicators. you cannot manage what you don't know. So you have to keep, your data, and then you'll always have a way of, assessing out if you're improving or if it's declining. And this will be aligned with each one of your significant energy users in the plant. And of course, energy baseline. So measurement and verification guys will be very happy with this, because now it forces you to establish a baseline right from the beginning. You draw a line in the sand and say, this is where I started. So if somebody has to come and measure my improvement, this is where they're going to start as well. So there's no going back and forth as and when it suits the individual. So that's the beautiful thing about this. But of course, now, sorry about that. So now we've got all of this, the policy. Once you've put together your policy, your objectives, your energy efficient design, it speaks to the different aspects about performance. So the main reason why you have to put this in place is not just so you can get started, it's so that you can be sustainable once you become ISO 50001 certified. So some of the terms and benefits, and I'm going to run very quickly on this because I wanted to show you that everybody, regardless of the size of the company, regardless of the industry, you can benefit from being ISO 50001. So you can go for ISO 50001 certification. And I'm also giving a global perspective as well as a South African perspective, which I'll tell a story in the end. So obviously, the adoption for ISO 50001 was one of the fastest. If you look at the history of all the standards, it makes sense to me. I don't know if it makes sense to you, but I'm hoping that this presentation will help you to make sense of it. But I'm also leaving some of the question marks so you can call me later on so we can discuss this. Trust me, I will not come out of your plan without convincing you that this is the way to go. So we'll also look at ISO 50001 being a culture of efficiency. More than anything, you need a culture of efficiency in South Africa right now, be it water, energy, resources. So every resource that you have, remember there's an aspect of scarcity there. So we cannot afford not to be efficient. So ISO 50001 also looks at that. Like I said, it's a performance standard, but it's also flexible to work with the rest of your standards that you may want to be certified for or you already have certifications for in your organizations. But ultimately, if you are improving and if you are doing well, you don't need to have a wait for the certification bodies to come and give you do a certification in your plan. You will see the improvement. You will be lowering those kilowatt hours, but also you'll be saving your money. You'll see it on your energy bills as well. So if there's an improvement, it's almost immediate. You will be able to pick it up. Like I said, it's the fastest growing standard. The first 12 months were amazing because some of the companies that we weren't even thinking of were able to adopt this. Of course, not South Africa. I mean, we're talking about the likes of Germany, your Spain, your Denmark. And the reason for that is because they had already a similar standard, that was a regional standard that we didn't have to concern ourselves about, called EN 16000. So that worked to their advantage because it was very similar to 50001, and it gave special attention to energy. So the trend in South Africa, the uptake is generally great for multinational companies that have headquarters in Europe. So if your head office is in Europe, case in point, think of your VW, your BMW as well. They said, when they came to us, they said, we want to be certified because head office says we have to be certified. So the pressure comes from above. Also, the OEMs, like I said earlier, they would say, you know what, all our suppliers, we're giving you in 4 years' time, you have to be ISO 50001 certified. Or you've got to show us that at the very least, you are implementing energy management system. So that's one of the drivers. I'm disappointed and proud at the same time. Proud because I understand that it's not easy, and most of this company we've worked with. But also disappointed because I know South Africa can do better. We can actually have more companies certified. So far, in my register, and it doesn't exist anywhere, we have 31 companies in South Africa that have been ISO 50001 certified. There's also the back and forth because they have to be recertified, otherwise you lose the certification. So if you don't go for recertification, we don't count you in. While you're working on it, maybe in 3 months' time you'll be certified. In that 3-month period, you are not certified. So there's that bit of going back and forth as well. And out of those 31, we've worked, NCPC, the IEE project, we've worked with the 24 sites. Different methodologies of work, and I will tell you stories about how we do it. And 96% of those are already familiar with ISO standards, or they've already implemented one of the ISO standards, either 9000 or 14001. But the message is we need to get companies certified as soon as possible. Right now, there isn't a direct support in terms of incentive to support ISO 50001, so you pay for yourself. NCPC, we pay for everything else, but we do not cover your certification fee, unfortunately. And in terms of energy management system, we get more companies coming to say, we want to save energy. We're going to implement energy systems optimizations. We're going to implement energy management systems, but we're not going to be going for certification, not yet anyway. So out of those, only 11% go through to be ISO 50001 certified. So these are just some of the numbers. ISO takes a while to give the stats. So I felt in the absence of the fresh stats, this is what we have. And this just speaks only on ISO 50001 in terms of the uptake. So it's one of those standards that everybody went for. So the aspect of being a performance standard about ISO 50000 has really worked for companies. And as you can see, these are the top 10 countries that have become ISO 50001 certified. It is also heartwarming to see that India and China, having some of the biggest industrial sectors in the world, have gone for certifications as well. And of course, we don't feature in that. It is my dream, and I hope I'm planting a dream in your hearts too. So the whole point of doing all of this, why even bother with the standards? The aim is to just make sure, and according to our ISO, they're saying if we, as industry, as buildings, as any sector, as South Africa, go for ISO 50001 and remain sustainable and become recertified time and time again, by 2030, we will have ensured access to affordable and reliable energy. So ISO 50001 is one of the solutions to that sustainability thing I spoke about when I introduced my topic. So let's look at early international adopters, and some of them you already know that, and some of them will surprise you. So in terms of electronic manufacturers, we have ABB that said, we will look into it. And you know Siemens is very big on energy efficiency and renewable energy as well. We've got the pharmaceuticals represented by Pfizer. As soon as the standard was out, they were ready for certification. And we've got airports. In South Africa, we've got King Shaka Airport that has been ISO 50001 certified. And of course, we've got Delhi International Airport, one of the busiest airports in the world. Food and manufacturing, we have Lint. In South Africa, we've got Mondelez that implemented energy management systems but did not go for certification. So we know that they actually applying the same principles. We've got Hilton Worldwide, so this was a group certification, so all the resorts have been ISO 50001 certified, and they continue to be certified as well. And I've got tire companies as well. And the US of A were very slow because for their own reason. If it doesn't come from them, then they have to interrogate it and faff around it until they're happy about it. But of course, in the ISO committee, some of my colleagues are from the US. So finally, in 2012, we're able to get Nissan to open the doors for most of the American companies and become ISO 50001 certified. And of course, we've got Lamborghini in Italy. Well, they tell me their cars are not very fuel efficient. I don't know about that, but I know that their processes are very efficient, so much so that they become ISO 50001 certified. So coming home, I have put together a list of companies, and these are the companies that we've worked with. You may know a company that's ISO 50001, and if you don't see it here, it's because we didn't work with them, but doesn't mean that they're not certified. So they're certified, but we didn't work with them. So these are just some of the companies that we've worked with. Some of them are multi-site. So you may find a company in Gauteng, maybe two in Durban or in KZN, and another one in the Western Cape. So this is the list of the companies that we've worked with. I have a quick case study which I took a snapshot of. This is also one of those interesting stories, but it's also a Gauteng-based site. They were not one of the first companies to be certified, but I spoke to their GM, their former GM now, and he said, you know what, Faith, I've always believed in this, and I never understood why we're not having something like this. I want to be certified, and I want to be one of the first one in the Zimco group. And within 6 months, the guys were training, the guys were hard at work, and I was going up and down like a headless chicken, but within 6 months, they were able to get their certification. So the long and short of it is that we know there are challenges to implementing ISO 50001. Most of the challenges are related to support, the technical know-how, the skills, staff turnover. Companies are skeptical. They don't want to send people for training because once you are trained up, you are better qualified to leave and get a better job with a better salaries. So they're scared of that, and we understand that. But we've designed energy management systems as per ISO 50001 to address those challenges. And we, as the IEE project, will support you right from the beginning where you say, I don't know what I'm talking about. All I know is that top management said, I will be certified, so I don't have a choice. We will take you through the whole thing. We will train you, we will train your teammates, we will train everybody, and we'll make sure that the kind of training that we do there, you will be able to replicate it if you've got more than one site. But also, we understand that you're still running around trying to get your 9001 or your 14001. Fair enough. We will make sure that ISO 50001 does not interfere with those plans of yours. We also want to make sure that to adopt this, it shouldn't be a cumbersome thing where you stop everything else. But it also doesn't give you an excuse to stop focusing on the other important things, your safety, for example. So ISO 50001 is not there to say, stop everything else and focus on this. So when you're running business, you will include this. So this is going to be your new way of running your business. You can't be running business as usual if you want to be one of the most sustainable companies. So the other problem that we picked up is that if you look at our case studies, most of them are medium to large organizations. SMEs are still facing a mountain of a challenge. And there could be a whole host of reasons, but one of them is because CEOs of SMEs are also engineers, they're also marketing managers, they're also the technical guys, they also change the light bulbs. The guy just doesn't have enough time to go around. They're usually very short-staffed. But also the biggest challenge is simply because they feel it's good enough for us to save energy. We cannot go a step further and pay money so that we can be certified. So what you think is minimal cost to you could be a lot for an SME. But we have a solution for it. In one of those standards that I said they are upcoming, we have 50,009, and that will address the multiple organizations. So if you've got teeny tiny companies, they can come together and have one certification. This is not a standard on its own. It's merely a guidance document. So ISO hasn't finalized this, and obviously SEBS has not adopted it. So as soon as science has adopted it, you'll be able to get your hands on this and get together with your fellow SMMEs or your SMEs, and then you can have your group certification. It is possible, and I was one of the biggest advocates for this as well. So the legacy. My presentation spoke, I said it's 2050, so ISO 50001, 2018 and beyond. And the legacy, more than anything, is a story about companies that will help. I can tell so many stories, but I prefer that you go look at the case study. So I will tell you a quick story of this company, First National Battery. So I can call them FNB, but I don't want to confuse a lot of you. We're not talking about the bank. So this company, I think it was last year when David Botha, actually my colleague called first, Inga. He said, I have 4 companies that want to be ISO 50001 certified, as in yesterday, but they haven't done anything. I said, okay, where are they? He said, they're in the Eastern Cape, there's one in Gauteng. So, okay, fine, I'll run the Gauteng one, and you can help the Eastern Cape ones. And he felt, to make this process faster and easier for the company, we'll contract some of our great experts. And we contacted Davifori for the 3 Eastern Cape sites. And I said, I'm not going to contract anybody for Gauteng. I'll do it myself. And this gentleman was not so worried. But of course, he was thinking, why are they getting something else and I'm getting something else? And we spoke on the emails. He said, I want you to commit to this on the email. And I said, well, I want you to achieve 2 things. We can kill 2 birds with 1 stone. So once we are done, you will be ISO 50001 certified, but you will be an energy management systems expert. And I will personally help you. That's why I didn't contract anybody, and I'm not going to. He was worried, and as we finalized it, and he came through for the training, and he said, can I see you when I'm there for training? I said, I'll come and see you. And during that week when I was sitting in my office, he didn't wait for me to go see him. He walked into my office, and the minute he took one look at me, that worry just became more apparent in his face. I was heavily pregnant. And he thought, how are you going to help me? I said, well, number 1, I do train experts, but also I'm an NMS expert myself, so I will personally help you to do this in the shortest time, and you will be the fastest in your group in class. And he said, has this ever been done? I said, not in this way, but this I've done before. But he wasn't convinced, and then he said, can you still type this in an email and commit to it? And I did that. And of course, he had more questions, and he copied everyone. And he called Inga, and Inga called me, and I said, I will do this. Fast track the long story. He attends the training. The following week, I'm there. And I can slowly see that I'm putting his mind at ease. We start doing the training. Almost immediately, we start doing the training for the guys on the floor. We start doing training for top management. We start doing training for the engineers. And I'm having all these meetings and these trainings, and I'm getting a lot of help from some of our experts. And we're doing this. And I said, if you're not sure that this is going to work, I have somebody that you can speak to. And that is the people from Zimalco, this case study that I showed you. And he spoke to them, and they said, actually, even better, you can come through if you want to see what we've been able to achieve. And that happened, and I said, the last thing I'm going to do before I go on maternity leave, I knew when I was going to give birth, and I said, the last thing I'm going to do is make sure that you are ready for ISO 50001. Now your people are trained up, you've got your significant energy users, you've got good plans, you've got your energy policy, you know what you're doing, but the last thing I do, I will go through that and give you sort of what I call a mock audit. So I'll audit you as though I'm the lead auditor, just to make sure that everything is in place. And we did that, and that was the last plant I visited just before I gave birth. And when I was on maternity leave, he called to say, not only did I pass stage 1 of ISO 50001 certificate, auditor certification, I've also already scheduled the stage 2, so it's going to happen this year, this November. And they did that, and they got the certification, all 4 sites. So the 3 in the Eastern Cape and the 1 in Gauteng. What I'm saying is that there are different ways. You may feel, I went to that side, or I looked at that case study, and I'm happy with what they did. I want exactly that. It may not happen exactly like that, but it will happen, and we will make sure that you become ISO 50001 certified. And these are just some of our legacy stories. And if need be, we will make sure that we have resources, we'll assign resources for you, and we will personally, all of us come there to make sure that we assist you to become energy management, to implement energy management system, but also to become ISO 50001. So if you have any questions, you will get our details, but there's also my email address and my telephone number. Thank you.
Thank you, Faith. I hope that just make your appetite for implementing ENMS grow even bigger. And if there's anybody in this room who's still saying, well, I'll just implement energy efficiency on a project-to-project basis. I'm passionate about this, and I'll drive this in my company. Ask yourself the risk associated with that. If you were to leave the organization or you get assigned to another different portfolio, will the work that you're doing be sustained? And that's where implementing an ENMS system will assist you, the sustainability of all the efforts that you're making towards improving energy performance of the organization. Having said that, we're now going to move into now projects, or rather ways in which you can optimize some of energy systems you may have in your facility. And we're going to present the case of energy optimization case studies for refrigeration system, with Kevin sharing us some of the work that he's done in industry. Welcome to stage, Kevin.
Good morning, everybody. Can you all hear me? Great, thanks. Can I have a show of hands in the audience? Who cares about energy efficiency? Any with no hands? All right, okay. All right. Who are those from out of town, staying in a hotel or a B&B? A show of hands? Few, great, okay. Of those people, who did not switch off the hotel room light or the bathroom light this morning? Really? I can't remember. Yeah. All right, so I'm going to kick off my short presentation with a story about a shoemaker in a small village a couple of 100 years ago. So it was a small business, and it was run by a father and 2 sons. And they had a good business, and they were producing the shoes for the local village people. And then all of a sudden, the business started to taper off a bit. They started selling less shoes, and business wasn't looking too good. So the father said to the 2 sons, "Look, guys, things are really not looking good. We're going to have to make a plan." So they said, "You know, I've heard about this big city over the mountain, on the valley on the other side, where there's a whole lot of people. Why don't the 2 of you go down over there and see if we can pick up some business?" So the 2 sons agreed. They said, "Okay, we've got to do something here." And off they go over the mountain, down the valley on the other side. It took them nearly a week to get there. And these 2 guys arrive, and they look out on this huge city, thousands of people. And the one son says to the other, "Look, this is a big place. Why don't you go take that area on that side, and I'll go down here. And then we see how it goes." And we meet back at the shop where Dad is. So off they go. And anyway, about a week later, the one son gets back to his dad, and he says, "Dad, you won't believe this. There are thousands of people there, but it's really bad. None of them wear shoes. I don't know what we're going to do. It's terrible. I'm really depressed about this." And Dad said, "This is not looking good. Let's see what your other brother has to say." So a few days later, in comes the second brother, and he says, "Dad, you're not going to believe this. There are thousands of people there, and we are going to make a fortune. None of them wear shoes." So that's an analogy I use for looking at energy efficiency. You can look at it with shoes, without shoes. It talks to the power of one. It's in your hands. Did you switch off the light in the bathroom this morning? I mean, it's a simple example, but it speaks volumes to how we approach these things. And from our perspective, over the last few years, it hasn't been easy. We started out as the second guy thinking, "There's some nice opportunities here." And we saw them. They were cheap. They were easy. But it turns out cheap and easy is not common sense. So what we thought is common sense is not commonplace. So I'm going to get on to the next. So this is a presentation that I gave last year in July in the United Nations headquarters in Vienna, at the UN headquarters. And I'm going to gloss over this presentation and give the background to it, so we set a context for the rest of my talk. So it was quite a stressful time trying to up my game to speak in front of all these important people and clever people, but it went quite well in the end. So these are some of the companies that we've worked with, and I'd like to thank the NCPC for the good work that they are doing in the marketplace, and commend you and Alf and your team of hardworking project managers and the good work that the NCPC does, and have worked with some of these customers, including the one where we did a case study at ZZ2 Tomatoes up in Messina. And the point of my talk, and I had to, let's say, take out the technical and academic side of it and get the message across, because the audience there was a very wide range of people, from academics to non-academics, let's say, and to explain to them the context of what we were doing there. The South African market and the varied temperatures. So giving them some statistics about the country and where I'm based. Our company is based in Cape Town, so we've got some hot and dry conditions up in the Kruger Park. Johannesburg is altitude 1,800 meters, which is its own challenges for air conditioning and refrigeration systems, and of course, quite hot and humid in Durban. So these are the places that we have done assessments on refrigeration and air conditioning systems. We measure it scientifically, and the data that we draw from those systems is not our opinion. It is the way that the plant operates in those conditions. So we have a range of sectors, from food manufacturing to pharmaceutical companies, and we have a lot of in-field data to support our claims. So working from all the way up in Messina, right down to Cape Town, and all the way in between. Again, this is a context to the guys at the UN. So ZZ2 tomatoes, I'm not sure if any of you are familiar with them. They are the largest manufacturer, or largest producer, of tomatoes in the Southern Hemisphere. Nearly 200,000 tons a year. 9,000 employees, so not a small company. They have 9 farms in total. So they had some problems with their chillers, supplying one of their food processing halls. It kept tripping on high head pressure, continuous failures and failures and failures. And they were at their wits' end. They were considering replacing the 2 cooling towers because they thought this is a problem. These things are too small. They're not working properly. So we measured the system, so using our methodology. It's a non-invasive system and produces scientific data out of measuring the performance and the efficiency of the plant. And at the end of the day, what we discovered is that the pump supplying water to the cooling tower was oversized. As simple as that. If you take a hose pipe and you squeeze the end, the water sprays out in a pattern out the side, and that's not efficient for the cooling tower. It doesn't work well. It's not able to reject the amount of heat that is required. And also what it does is the water splashes over the side, out of the side of the cooling tower, and they have a chemical treatment process to keep the water clean. And what was happening is the chemical process, because of leaking water, the chemical system was overdosing. So we measured the capacity, the design capacity of the plant against the measured capacity, and we could see it's underperforming. Why was it underperforming? Because of the spray systems and the chemical dosing. So the solution there was very simple: install a regulating valve to reduce the flow of the pump. We got them to clean the condenser using a chemical descaling process. And the cost of the intervention was 1,200 euros, compared to changing the whole tower, which would have been 10 times that amount. So capital investment was 0. So at the end of the day, the outcome of that was improve the cold chain, because they're cooling the tomatoes. They weren't able to maintain the cold chain because the chiller kept tripping off. They were able to increase their production. The efficiency went up. The lifespan of the plant was increased because the chiller is now not breaking or tripping off, not running out of its envelope. And we reduced their CO2 equivalent. So a good story all in all. And when you accumulate this over time, it's significant savings. So again, coming back to a wide range of industries that we measure: property sector, supermarkets, agriculture, dairy, food, other. We've probably measured in individual systems, probably 150 individual systems across the country now. So the conclusion of this section of the talk was that you need to measure it before you know it. This is obvious. But what we find in the market is business as usual. If it breaks, we'll fix it. Unless there's a problem, there's no problem. Number 2, small interventions can have a big impact. Remember that air conditioning and refrigeration systems, by and large, run 24 hours a day. Comfort cooling applications, maybe not. But if you can make a small change, it magnifies itself. It's a leverage. And we can say confidently, based on in-field scientific data, that on average, this is high level, of course, savings of 10 to 30% are normal. And 80% of those are with non-OPEX. There's only in OPEX money, not capital interventions. So I'm going to go out here. Bear with me. Right. Okay. So I prepared a mind map, throwing in some keywords, and also just giving an overview of the outcomes, some bullets of the nuggets that were the takeaway of the 3-day conference in the UN, and then also to try and flesh out a few practical examples of how I can relate. This is quite a technical and detailed topic into a wide range of audience. So I've tried to avoid graphs and numbers and all sorts of academic side to this. So the nuggets on the, let's say, the takeaway. Small interventions such as cleaning condensers have significant benefits in terms of energy. And this was not only my presentation, but some of the others were also along the same lines of what can we do to improve efficiency without replacing the plant. We can optimize it, we can clean it, we can make sure the maintenance is done correctly. Replacing refrigerants with, let's say, harmful refrigerants with modern refrigerants that are less harmful to the environment doesn't really increase the efficiency. People have this idea that I put a more environmentally friendly refrigerant into my chiller or my refrigeration system and it's going to be more efficient. In practical terms, it doesn't really. The increase is so small that it would be negligible. Sorry, can we turn that off, please? Okay, thanks. Poor efficiency, sorry. The other element from the outcome of the UN was that the cold chain is affected by efficiency, and that leads to food waste. If the plant is not efficient, the cold chain isn't maintained. And we saw that with our own measurements at ZZ2 tomatoes. In general, people are too quick to replace something. People have this idea, well, the chiller is, let's say, 8 years old. I'm sure it's old and it's not working well. Let's replace it. But that's not actually the case. And it's too often the default position to do that. But the Montreal Protocol is a success story since its inception. If you look at buying a car today, you cannot buy a car with R12 gas in it. You don't buy a fridge with R12 gas in it for 15 years more already. Why is that? Because there's legislation. There's legislation. People don't do it because it's against the law. Okay. So that bears out the idea of having a stick approach that can work. Right, cooling efficiency. That touches us every day. Your fridge at home, your air conditioning in your office, air conditioning plant in your car. We don't know it. It's just there. We have air conditioning. There's a massive chiller running somewhere that's using a whole lot of electricity to keep us on temperature here. It's not something that's in your thoughts. The light's on. You can see the light is there. It's a product of what you can see, but air conditioning is much more, let's say, subtle. And again, that they operate 24 hours a day. What is the difference between efficient and effective? Well, effective is my temperature in my office is okay. The chicken is cold or the chicken is frozen. And that is a major problem for us. It's a barrier into the marketplace. People think my office is at 22 degrees, therefore it's efficient. It's maybe not efficient, but it is effective. The fact that it's effective in your office at 22 doesn't mean that it is efficient. There's a big difference. Oh, sorry. So talking about COP, coefficient of performance, I won't dwell too much on that. The COP is a ratio of what you put in to what you get out. And the point is that the leverage effect of changing, implementing some small changes on the system improves dramatically. It's a leverage effect. And I say nothing happens in theory. We can design things, we can have our graphs and performance factors and models and things, but at the end of the day, somebody's got to go to the plant, implement those changes, and measure the effect afterwards. Perishable products, again, nearly all food comes through the cold chain. If you ate an apple this morning, that apple was picked on the farm, put into a cold chain system, on a truck, refrigerated to the supermarket, in a display case, and you picked it up and you took it home and you put it in the fridge. It's come a long way to get there, and unseen energy and efficiency. The cold chain uses energy, it uses water, and there is waste. Again, the food waste comes from a plant that isn't effective to keep the cold chain going, but it's also not efficient. So we were able to see some data in the UN to back that up. All right. Water efficiency and cooling efficiency. It's not commonly known that there is a link between those two. And referring to the idea of the COP and the efficiency of the system, the more efficient the chiller is, the less water it uses at the cooling tower. And that's a significant amount of water. They are directly proportional. So this is the theory. So here we can see the heat being rejected from the system on the left, leaving into the cooling tower. And it might not be obvious to everybody, but a cooling tower uses a lot of water, a lot. People see the fan and these systems. So there's a good example. I don't know if you've recognized this one. Those who pass through our Tambo on a regular basis, these are the big towers in the parking lot as you go through to drop off your hire car. You'll notice these on the left-hand side. So a group of towers like that would probably be in the 3 to 4 million liters of water per day. It's a substantial amount of water that gets used. Those fans on the top are not just cooling a set of pipes, they are evaporating tons of water every day. Yeah, it's one of our clients, and they wondered why the system wasn't working well. So this also speaks to the maintenance and the things. Okay, so you have to understand, what is your objective? Are you trying to save energy? Are you trying to save water? Or are you trying to save money? It's not the same thing in practice. In theory, it's one thing, and practice is something else. Okay. So just a little touch on what has become popular, especially in Cape Town with the drought, that we installed what they call a hybrid condenser. So a condenser is where the heat is rejected, like a cooling tower. The heat is rejected out of the system. So what is now coming into play is they use an air-cooled system with sprayers, or a water system that only kicks in when it's very hot. Okay. So now the problem with this is, if you go and look at the actual numbers, you'll see that the amount of water that you save is, yes, you might save water at the condenser as opposed to using a cooling tower, which needs water all the time. But at the end of the day, you're going to sacrifice energy. And when you sacrifice energy, Eskom is also using 1-point-something liters for every kilowatt hour. So this is something that is hidden, something that is not obvious. So you have a compromise in energy. This fancy hybrid system is going to be more expensive to maintain. It's more complicated. You need the right skills. The wet pads, the sprayers need to be unblocked. And if you don't do that, you're going to throw away the energy gains that you may have had. Return on investment, none. The water is negligible cost. So again, referring back to, what did you want to save? Water, energy, or money? So you have to be careful. This is a practical example. I'm not knocking the manufacturers of these hybrid condensers. And if there is no water, you've got no water. So a hybrid condenser might be essential, given it has its own place. But again, you have to look at the actual practical example of it. So what's the alternative? Well, use MNV to optimize the set points, maximize the maintenance procedures, and detect and prevent inefficiency degradation. Energy efficiency and optimization is not an event, it's a journey, it's a lifetime thing. You always have to make sure that it's not falling away. Another example, increase the temperature of the chilled water, leaving the chiller by 1 degree. You'll save a ton. Is it really going to make a difference in your office? I don't know. Switch the chiller off at night. How many plants we go to and the chiller is running 24 hours a day? Doors wide open, the chiller is running for no purpose at all. Again, these are practical things. Theory is one thing, but practice is something else. I see customers putting in the most high-tech chillers that money can buy, and they run it at night. What's the point? Okay, so coming back to the NCPC, I'm sorry, are we waiting for time? So the NCPC, we've done some work with them, and we've done some refrigeration system optimization assessments at SAB Newlands, AB InBev, Growth Point Property, up here in Pretoria, Rhodes Foods Group in Franschhoek and Cape Town. SA Breweries and Rhodes were industrial ammonia refrigeration systems, also with massive cooling towers using a lot of water. Growth Point Properties, they were all air-cooled systems. And if those 3 companies implement our recommendations, they will save millions of rands every year. The payback in some of those will be in weeks. I won't mention which ones, but some of them would require a set point change. A set point change. And I often get asked, but Kevin, we don't need your fancy system to tell us that. So my reply is, well, why is it like that in the first place? Because nobody looks at it. It's just out there. Cooling efficiency is not something that's in everybody's forethoughts. Interventions mostly are OPEX. 80% of the savings come from changing the set points, optimizing, checking the maintenance, maximize the maintenance. What drives companies to change their behavior? These are just some keywords I've thrown on the paper in closing here. Offset credits. We know for a fact, we can prove it, that maintenance, repairs, and energy are an outcome of measuring the system accurately. To decrease the operating expenditure. If a chiller is running within its envelope and it's efficient and it's happy and it's healthy, it will last twice the amount of time that the manufacturer says. It is not necessary to replace most of the systems that get tossed out. The stick, carbon tax, cost of energy, and some other ideas here. The scarcity. If electricity was as scarce as the water was in a drought in Cape Town, the idea of energy efficiency would be a whole different kettle of fish. And I come back to the 2 brothers getting back to the shop. There would be a massive change in approach if electricity was in short supply. We saw this in Cape Town. People did and implemented things that could reduce the water consumption. What is the magnitude of the pain? If I look at a supermarket, we've done a number of supermarkets. This typical franchise supermarket might have a turnover of 15 million rand a month. His energy bill for the refrigeration might be 200,000 rand a month. So you go to the guy and say, well, we can save you 20%. Oh, okay. With that money, I can buy a new camera system to prevent shrinkage of my goods receiving. So the conversation is in the context of that. What we see, and I'm going to end off on this on a negative note, unfortunately, is that the reality is, in practice, a lot of companies pass on this cost to the consumer or the customer. It gets passed on. And it's one of the reasons I believe that, philosophically speaking, our economy has been stressed in the last 12 to 18 months. One of the contributing factors. It impacts the cost of food. It impacts a lot of things, the rent in a commercial space. All of that gets passed down because it's not measured correctly. Nobody's acting on it. It's not something that's in our forethoughts. And competitiveness. If I have a dominant position in the market and whether my operating cost is X or Y, if I'm still competitive, then I don't worry about it. I'm sorry to be negative, but that's been our experience in field. So yes, in closing, energy saving is common sense. It can be done and easily and cheaply. If you measure it correctly, the savings are multiplied and the systems run 24 hours a day. It has a huge impact. But common sense, ladies and gentlemen, is not commonplace. So with that, I'll close off and thank you to Monetary. Thank you for your time. Yes.
I like what Kevin just said. Energy efficiency, energy management is not an event, it's a journey. And I think nothing makes energy efficiency or energy management as personal as when you start thinking about it as a consumer. And the point that Kevin is really introducing is quite key. You may be thinking, well, this is all about industry, but what do I as an individual have to make an effect in effecting change in this space? And he introduced quite an interesting point around how costs are passed on to consumers. So you see how each one of us can play a role in changing or shaping the South African economy. And nothing makes energy management or energy efficiency more personal than thinking about food, right? Both from cooking and cooling of food. So every time I think about whatever we're putting into our stomach, I like what he said about asking ourselves, is this effective or is it efficient? this cooled or chilled environment that I'm enjoying, which for me is effective, is it really efficient? Can I, as an individual, really make an impact that if we collectively do that, we can see incremental change in the patterns of consumption in our country? With that said, I'm going to now introduce Larry Pratt. So far we've been talking more around the consumption side, the demand side of energy. And like I said, the full conversation also includes carbon management. And we mentioned how energy efficiency is that starting point. And once you've implemented any energy efficiency measures, you also want to now start thinking about how can I introduce low carbon energy sources in my facility. And Lawrence will introduce some of those concepts, as well as tell you more about the facilities that CSIR offers for companies that have matured in their journey and they want to consider some of renewable or alternative sources of energy. Over to you, Lawrence.
Okay, thank you for the opportunity to talk here this afternoon. I think I'm standing in between you and lunch, so I'll be brief. So this is the topic of the talk here is supporting the transition to solar PV energy supply team and our role in transitioning to a low carbon economy. Can I see the screen here by any chance, or it's not on the monitor? Okay. So this is a brief outline of my talk. We're just going to introduce kind of what solar PV is doing globally and domestically, what we're doing here at the CSIR, just right down the hill from where we're sitting, some of the services that we can offer you and maybe some of your clients around pre-feasibility studies for solar PV plants, systems on their facilities, and what we're doing in terms of the quality and reliability of solar PV plants just on the other side of the hill in Building 46. Okay, so many of you are aware, I'm sure, about the growth in the solar PV sector globally, 100 or so gigawatts per year in the globe going up, and that forecast is bright and expected to continue to grow. Here in South Africa, we have already about 1.5 gigawatts of solar PV connected and operational, and with the expected growth up to, say, 8 or 10 gigawatts by 2030, according to the ESCOM draft IRP. So there's going to be growth here in solar PV, we expect, and there will continue to be growth globally. And so we want to play a role in that to help ensure a successful transition. This is an image of some of the output that we get from our own PV power plants here at the CSIR. We've had our first plant, the ones you see on the N4 particularly, right? The single-axis track plant, that's 558 kilowatts of tracked PV. Right next door is 203 kilowatts of dual-axis tracked PV. And then we put up a rooftop system on Building 17, and now we're in the process of commissioning another 5. Thank you so much. We're in the process of commissioning another 5 rooftops, which will bring us to a total of about 2 megawatts of solar behind the meter here at the CSIR. So it's pretty exciting for us. We're practicing what we preach, if you will. And what this graph shows is some decline in our consumption from Swanee in the blue bars. Our rise in the solar PV contributions is the red trend line, and the colors are some different PV plants. So what you don't see here right now is the additional 911 kilowatts of rooftop that are currently being commissioned. So we're moving in the right direction there to transition the CSIR Pretoria campus from carbon-based to non-carbon-based electricity. So in summary, kind of what we're doing here to support the transition, I think, we're building our own PV plants at the CSIR. We're doing quite a bit around human capital development. We have a number of students who come through from the various universities to learn more about solar PV and operations and maintenance and testing and certification and modeling. Or we're ready to take the step and take a look at this. What does this next step in the journey mean for us? And we're also developing infrastructure here to really focus on PV module quality and reliability testing. We want to make sure that when this transition happens, as it's happening, and we fast forward 5 or 10 years from now, we actually have functional, efficient solar PV plants online. We don't want these things to be failing early, degrading more than promised, and so on. So our focus is really about getting it right now so that we can reap the benefits over the 25-year lifetime of a plant. So in the end, it's really reducing the risk of deploying PV. So on the pre-feasibility space, what we can do for clients is really just to kind of introduce the idea of solar PV and maybe what it can do at a high level for their operations. So site visits, location assessments, how much land do you have, how much rooftop do you have, does it make sense to put PV here, are you really ready for that? What are some of the potential pitfalls you can find? The soiling loss there is an interesting one in the top right corner. I was a bit shocked when I came here in 2017 in the middle of wintertime and just saw really dirty solar PV panels. And it turned out that our single-axis tracker plant had gotten basically 20% loss. It was performing 20% lower than it should have been if the modules were clean. So dry season soiling is a real issue for the output of a solar plant. So how do you manage that? First of all, manage that expectation and then put in the proper O&M to handle it. But it's a real thing here. Bottom left-hand corner, kind of insulation, right? So the fuel for a solar PV system, of course, is the sun. This fusion reactor 96 million miles away, sending us tiny little photons and converting them into electricity. It's really kind of amazing, right? But that only works when the sun is shining, and then, of course, when clouds come and storms come. So there's some variability in the resource. So we have to understand that. What kind of resource can you expect? How much fuel can you expect in the wintertime versus summertime? And how does that line up with your load? What is it that you're trying to power with this renewable energy? So there's some uncertainty there. So that's the bottom center graph. You can look at P50, P90 kind of analyses and say, what would I expect, and would I expect this power plant to produce, 90% of the time, 50% of the time, 10% of the time, and size and plan accordingly. And ultimately, you take all this uncertainty and you put it into, this is what we expect your plant to produce for you, each month of the year for the next 25 years. And how does that fit with your appetite, your budget, and your needs? We can also help with the business case analysis. We have some calculators of our own that we've developed in spreadsheets. There's other software you can use to do it. But the idea is to try and think about this investment in terms of what's the levelized cost of energy. If that's a new term for you, that's simply like what you would expect to pay for electricity over the lifetime of the plant. So there's the CapEx and the OpEx, but you're going to produce energy from that system over 25 years. When you do the economics and look at net present values and so on, you get down to a levelized cost of energy. And as the graph shows on the right, we've shown here at the CSIR, based on real data from IPP contracts based on the REAP program, distributors at 62 rent cents a kilowatt hour, which is pretty incredible. You may have seen there's other reports that come out in the news occasionally internationally, the competitiveness of this business in places that have high resource and good climate is really quite incredible. I think some of the best numbers I've seen come out of Argentina. It's a high, dry, cool climate, so the solar PV, that's perfect for solar PV. We've got pretty decent temperate climates. We've got a good solar resource. We should also be in that sort of competitive space. And one of the interesting things from my point of view, one of the projects I worked on before I left the States was helping Facebook locate a data center in New Mexico, which is where I'm from. Facebook and other companies like them, they want a 100% renewable energy portfolio across their global fleet. And so they're looking for places where they can get the cheapest, most reliable renewable energy. And New Mexico happens to be a place like that, very similar actually to South Africa in terms of climate. We're also at about 1,500 meters. We have a lot of clear, sunny days and a lot of cool days as well. And so based on that and a number of other factors, Facebook decided to build their plant number 8 with 30 megawatts of distributed solar. It was a cooperation with the state and the local utility. We have our PNM, our Public Service of New Mexico, which is a lot like an ESCOM. They came in and they said, well, if you do 10 megawatts over here and 10 megawatts over there and 10 megawatts over there, and we do some accounting, we will basically sell you electricity at such and such a price. Facebook gets the tax credits and cheap electricity, and PNM and New Mexico benefit from it doubled or quadrupled the amount of PV solar we had on the New Mexico grid in one shot. And the cool thing was nobody had to pay for it except for Facebook. Anyway, that was a huge digression. I apologize for that. The bottom slide here is sort of matching generation and demand profiles. That's another important thing to consider when you want to do solar PV. So the value really of this part of our offering is to provide a basis for a go, no-go. Does it make sense to pursue? It'll also provide the client a basis from which to evaluate bids, right? So if the decision is to move forward, the tenders are issued, bids come back, and bidders are going to have different value propositions, price points, mixes, technologies. What does that all mean? So it's a means to provide the client some education and some further understanding about how these things operate. It's not a blueprint on how to build a PV plant. That's what the commercial sector is supposed to do, right? So we're just here to help the potential owner of the plant make the right decision when the time comes. So the second part of what we're doing, so that's the planning part. The second part of what we're doing is really trying to improve the quality and reliability of the plants. So we don't want to be 5 years into this and your client comes back and says, hey, why isn't this PV plant doing what you said it was going to do? So how do we avoid that risk? There's a number of ways to do it. First is to kind of understand what the risks are, and I kind of grouped them into 4 areas here. And I think one thing that I see quite a bit, not just here, but everywhere, and the numbers are being published in journal articles, plants are underproducing on average by, say, 3% globally, I think is about what we see. So why is that? Well, honest mistakes happen. Those can be disastrous. We want to avoid the honest mistakes. We can have weather file inaccuracies. So again, your weather file is your fuel, right? So you want to have your predicted fuel resource well understood. If you overpromise the amount of fuel going into the plant, it's going to underdeliver. Overselling to win a bid, I think that's a real problem, right? So it's, you're competing with 5 other companies, and so maybe you want to just say you can get a little bit more out of this plant than you know you really can. Module degradation and quality, we think that's a real risk, and certainly globally that's a potential risk. In general, solar PV panels are built well. They're made to last 25, 30 years. But you can occasionally get a bad batch or a bad, what we call bill of materials. The specific components from the specific manufacturers that come together to make a panel to operate over 25 years don't always work right. So we're there to kind of help screen that out. System degradation, operations and maintenance, a big deal, right? These plants, one of the nice things about solar PV plants is they're scalable and deployable. You build them quick and you can build them anywhere. So in a matter of months, you can have megawatts of solar PV online. But they have to operate for 25 years. So we don't want to underestimate the role of operations and maintenance in the overall output and the overall LCOE of this asset. And then finally, you have environmental disasters and grid availability, which I think is maybe more of a problem here in South Africa than I experienced in New Mexico. But when the grid is down, so is your solar PV, right? At least for large scale without battery backup. So that's going to impact your bottom line as well. So that has to be understood. We're going to focus on the quality and reliability of the components. Just like you think about when you buy clothes, phones, shoes, cars, houses, or whatever, quality matters, right? Quality is like, what is this thing doing for me now? How does it look? How does it feel? Is it built right? Does it have the material, maybe the brand that you want? That's quality now. Same thing goes with the PV panel. You want a good quality panel. Unfortunately, most of us in this room don't have the experience with solar PV panels, right? We can pick up an iPhone, we can pick up a Huawei and go, this one's kind of cool, right? Solar PV panels, maybe they're a little bit more mysterious for most of us. So we have some idea what that quality should look like, and then more importantly, what's that quality going to do over time? And that's what I consider reliability, right? So we have some new infrastructure with the help of TLIU and the CSIR and the Energy Center. We've come together with the funds and the resources to build up some environmental chambers to do accelerated stress testing. And a sun simulator in the middle there, which is our sunshine in a box. So for about 45 milliseconds, we can simulate the sunshine and measure performance of modules over a broad range of temperature and irradiance. So really nice equipment designed to help us assess the quality and reliability of solar PV panels. The chambers are designed to stress modules from 85 degrees Celsius to minus 40 degrees Celsius over multiple cycles. So a standard module certification would do that 200 times. For a reliability program, we'll do that 600 times. So the idea is you're simulating in an accelerated fashion the thermal stresses that happen on this solar PV panel because of temperature changes that they would normally see when they're sitting on your rooftop in the middle of the day versus in the middle of the night. Those temperature stresses can have a negative impact on all of the bonds, all the solder bonds and the different layers and the different material components within the module. So we want to try and accelerate that and look for failures that we typically would see in the field if a module is not built well. So there's other legs of the program. There's also on the right-hand side, you can see a mechanical load tester. We have that device there to apply mechanical stresses on the panels to simulate wind loads, snow loads, transportation, people walking across the panels to do maintenance, those kinds of things. You've probably seen pictures like that, and you're like, is that really good for the panel? If you've seen the Solar World company at trade shows, or used to anyway, they would have a guy on a mountain bike, bouncing around on a bunch of solar panels set up to look like so you have to look underneath. So there's electroluminescence imaging that we can do, which is like an X-ray for a solar panel. Just like you can't see if your bone is cracked, the X-ray can. We have similar instruments as well. So a lot of great kit. We're bringing it online now. We're kicking off a pilot program as we speak. We have 4 module BOMs, bill of materials, in this first phase. South African branded, 2 Chinese branded, 1 Indian branded manufacturer. Modules that are available in here is South Africa. We'll run them through this test program, which is this, we're following the CSA ANSI standard C450, which is really the latest in open source reliability testing for PV modules globally. So really, the CSR is Energy Center, and the solar PV team is really here to help reduce the risk on your next solar PV project. Okay? This is the test sequence that we'll be going through the modules. There's several legs there that, for example, the TC600, that's that thermal cycle that I mentioned, 85 to minus 40 over 600 cycles. The DH2000, for example, that's damp heat. So we do 85% relative humidity at 85C for 2,000 hours. And then in between, there's a humidity freeze. So there's really a lot of good science that's gone into developing these standards and these sequences over the past 50 years. And it's really an international community that has come together to put this standard together. So we're benefiting from that, and we're going to implement that here and then hopefully convince PV plant developers, owners, financiers, insurers that this is value added if you want to ensure the quality and reliability of your PV plant for the 25 years that it needs to operate. So in conclusion, in summary, continued growth in PV sector is expected globally and in South Africa. Pre-feasibility studies are a great way to sort of get into the business with your clients and see if they're interested at a high level. And then certainly if and when it does come down to building the plant, we're here to help with the de-risking of at least the module quality and reliability portion. So with that, thank you very much for the opportunity.
Thank you, Lawrence, for that comprehensive presentation. Takeaway. Just on this topic, the Energy Center is there to help reduce any potential risk you may have for your next PV project. So these resources are available. We know that not everybody here has the technical background or skills to tackle some of these topics, but through the NCPC and through the Energy Center, we're there to walk the journey with you on both ends of demand side of energy and also the supply side. We have about 15 minutes left for our session, and I would like to use the remainder of the time to give you an opportunity to engage with our presenter and ask any questions from any one of them. I would like to invite all three of them to the stage so we can take questions. Okay. Any random question, just say to who you address your question, and we'll take three at a time. Yes, Siraj?
Yes, thank you. My name is Siraj Williams. Just to Lawrence, the modules that you're speaking about, will they become commercially available?
Sorry, I didn't quite get that.
Just repeat your question, Siraj.
Thank you.
Yeah.
Yeah, thank you. Very interesting talks from all of you. I'm glad I came to the session. Just in terms of the modules and things that you're testing, is there a plan to make them commercially available at all?
The service, yes, there's a plan to make the service commercially available, right? So we have a business unit that has certain targets for revenue. We do plan to use this facility both for research, human capital development, capable state, all of that business, but there's also, we are offering this service to the private sector. We've done some work already for a client that was doing a rooftop system, found some interesting kind of results there in terms of the module quality. We've also done some work already for a German manufacturer who wants to introduce a solar PV module mounting clamp in South Africa. So they contracted with us on that mechanical load tester to stress modules with their clamps on 2 different South African-made roofing profiles. So lots of interesting stuff here that can be done.
Okay. Thanks, Raj, for that question. Thanks, Lawrence. Just wave so I can see where you are. Okay. I'll take him at the back and then you next.
Hi there. Just a quick question, actually, to all three of you, seeing as it crosses all the spectrums. Unfortunately, particularly commercial-grade PV is highly erratic and unreliable. This is the nature of PV. Are there any efforts being undertaken to match the load profiles of production and supply? So, for example, matching how a site works relative to what the PV production is at that specific hour.
Okay.
Yes, for sure. I'm not sure what the first point there was about PV quality, PV module quality being low. Did you start with that? Did you lead with that?
It wasn't about it being low, it's just the nature of the sun is that sometimes you have high production in 1 hour and very low production in another hour. Just dealing with the unreliability of PV on a daily and
Oh, yeah. In terms of the output of the plant, yeah, sure. Yeah, so matching the solar resource, the generation side with the demand side is important. Certainly when you're looking at, when you're trying to come up with an LCOE or maybe the savings of the project, right? You want to make sure that you're producing solar when you're buying the most expensive electricity, for example. So we do have some work where we're also looking at optimizing the battery size and the PV size and the demand size. So we're doing some simulations in that space to say, this is the most cost-effective way to balance your PV generation, your load, and your storage to meet your cost objectives, let's say. And I think, in general, I think the answer for the variability in the solar resources is storage. So utility scale storage. We talk a lot about Powered X, and then using. So we. So you could produce your hot water in the middle of the day when there's plenty of solar resource, for example, and store that heat. You could likewise excess generation from renewable resources could go into your car batteries. Fast forward 10 or 20 years when there's maybe 10,000 or 15,000 EVs on the road.
Okay. The question from the lady at the back.
Hi, I think it's similar to his question. My question is, for companies, do you guys provide support in terms of sizing your solar PVs once you've decided to go to that route, or companies, or just, give recommendations on which companies could assist sizing or selection of solar PVs?
Okay, I think
Yeah,
this
for
is
sure.
still addressed to you, Lawrence.
So, yeah, so for sure, yeah, we'll help with sizing. That's definitely a fundamental question. And that's maybe limited by, first and foremost, by what's available in terms of land, open land versus, say, rooftops, for example. Then what can that generate, and then does that anywhere come close to meeting your demand? So sizing is definitely an important part, as is efficiency. So reducing your load to begin with, which I think some of our earlier talkers and have spoken to as well, is about that energy efficiency in an energy management system. Do that as well. If you can reduce your load to begin with, then the cost and size of your PV system gets smaller and more reasonable.
Okay, thank you. Yes. Yes.
Hi everyone. Just a quick one on cooling systems. What I actually want to ask is, what's your? Do you have any responses to that? What's your take on open loop and closed loop cooling system in as far as the efficient operation of the system, efficient and effective operation of the system? I'll give a practical example. And then water consumption, when we talk of vacuum systems, like we're trying to create vacuum through cooling.
I think this is for Kevin.
Yeah, okay. Thanks for the question. So to answer your second question first, I have no experience with those vacuum systems. I know that in Japan they have but I have no experience with that one. Could you explain the first question? Could you give me, so you talk about an open loop system and a closed loop system. Give me an example of that. Can you give me an example?
I can give you an example just to pick from one of the things I think you mentioned where you spoke about cooling tower.
Yes.
And then I can't remember exactly what was your other example. I think it's spray or something. But
yes, okay. All right, I got it.
Of a cooling
Okay.
tower system.
Right.
And then your heat exchanger, say plate and frame or
Got
shell
it.
and shoe heat exchanger.
Got it. Okay. So in the example of the ZZ2 chiller system, that was an open cycle one. So in other words, you had a heat exchanger or condenser, shell and tube condenser. And that's where your water consumption comes in, and it's significant. In a closed loop system, you, depending on how you, the different definitions for that, but you might call that a dry cooler, which is interesting because it's not dry, there's water inside. But it's yeah, so the same, you could still have a shell and tube condenser, and the water is pumped from there, carries the heat to the dry cooler, which is a finned tube system. So in other words, you've got a radiator, if you like, with air being drawn over that from ambient, and then obviously the ambient air that's doing the work. But then the hybrid system in general, the principle would be that when the temperature is very high, you could evaporate water with mist sprayers on the air entering side of that heat exchanger. And then there will be a control system that would know when to switch over to activate the sprayers or the wet pads or whatever it is that they're going to do. And obviously, if you use a dry cooler, you must remember that you are adding significant lift to the compressor. In other words, where it's the evaporating temperature or the low pressure to the high pressure is now added on, because you have to now sacrifice another temperature difference on your heat exchange at the dry cooler. Does that answer your question?
It actually gave me some insight, but not quite clearly.
Okay. Please join me afterwards.
Join him after the session so you can unpack that a bit more.
I think also,
okay, Faith?
There's a former colleague of mine from ESCOM. As you know, ESCOM has some both cool and dry cooling methods. And he's did a feasibility study on both and see whether for the new power station being Kusile and Midubi, which one they should go with. And he's got extensive results and he's done some work on that. So I can also get you in touch with him.
Okay. Two last questions before we wrap up. Gentleman at the back.
Hi there.
Hey.
On solar PV, are there any financial institutions, should maybe a client require to have a solar PV plant installed at the facility? Are there any institutions that assist?
That's a really great question, actually, because a lot of the financial viability of the solar PV project depends on how you finance it. And I think I don't have a clue about what's going on here in South Africa, but one of the things that we'd like to talk to going forward is the financial institutes to say, look, is there an opportunity here to offer some discounted loans for systems that have gone through some quality and reliability assurance checks? So coupling those two pieces makes a lot of sense, because then the owner of the plant can offset some of the quality and reliability testing by getting a better rate from the bank. In the States, people will do it. There was a PACE program, and I think there's actually some action here in that space too. It's Property Assessed Clean Energy, it's called. So this started in California 20 or 30 years ago, where they actually were able to repay the upfront cost, basically attach the cost of the system to their property tax. So the city took the risk, but they just upped the property tax on that particular piece of property until the thing was paid back. So there's a lot of really creative ways to finance solar, but unfortunately I just don't have an idea what the status is here in South Africa.
I think, speak to one of my colleagues, Mr. Art Heisenberg. Is Al still here?
Yes.
Oh, yes. But also NetBank has a program specifically for solar, and ITC as well. So we've worked with those two. Those are the ones that I know. But I know ALF has an extensive list of other companies that actually fund solar programs.
What I found is most of the South African commercial banks have quite matured financial products for renewable energy projects. We're working a bit more on energy efficiency, but on renewables, there are examples of loans that get granted for renewable energy projects like solar PV or solar water heating and so forth. One last question.
Hi. My name is
Yes.
Arshad. I'm an equipment supplier, and I see that on the ZZ2 project, it was a really nice, in-depth knowledge you have shared with us. Thank you very much for that. My question is that water cool system, you emphasized on a water cool chiller and then on the water being consumed by the cooling tower. What is your reaction that if we are replacing it with the air cool system, is it efficient enough or not? And if the last one is a small part of it, that if there is a technology where we can bypass a cooling tower, will you be interested? I can supply you.
Okay, all right.
We're making business deals here.
Should I frame my answer in that context? Okay, so that's quite a broad question. So, I mean, we measure things in field. So I'm less concerned about what the manufacturer says it's going to be doing or is doing, or that the supplier or the installer or the operator of the plant says it's happening. We measure it using scientific terms. So what we see in practice and what is in the model or the manufacturer's brochure, all those things are very seldom found on site, nearly never. So it's a little difficult. I think it's a little broad to answer that question directly, but you must understand that in practical terms, if you're using a closed-loop system, in other words, a dry cooler with fans and sprayers, you sacrifice significant energy loss on the compressor system because it has to overcome another layer of another energy boundary. So you have to be careful. You've got to do the numbers on that. So in other words, if you're going to sacrifice energy and you don't take into consideration the water that was consumed at the power station, that's not, strictly speaking, correct. So actually, you're going to spend more money because if the plant runs at a higher pressure, you're going to spend more money on energy. So you're not going to save on energy. You're going to spend, there will be an energy penalty to do that. So it really comes down to the setup and the design and the operation. It's great when the plant is nice and new and shiny and clean, but a year later, 2 years later, 3 years later, it's a whole different kettle of fish. Because our experience, the more efficient the system is, in general, they tend to be more complex, more complicated, more difficult to maintain. You need a high level of skill. And as time passes, these systems are getting very, very very complex, and you need a high-skilled person to do that. So, of course, if you have technology that can get around this problem, there's a huge market. I wouldn't be a customer of yours, but by certain we can, if there are places where the technology can be. And I would probably have a list of 10 customers right now where you could go and help them because they've got some significant problems. Of course, also, not to be fair, these cooling towers and evaporative condensers also come with their own set of issues. It's not just plain sailing there. But it's not accurate to think that, you know, if you put in a dry cooler with a hybrid sprayers, that all your problems are gone compared to, it's not that simple in practical terms. Thank you.
With you on that one. Just to close it up.
Very last question.
For everybody, the COP of a air-cooled chiller is 3, while for the COP of water-cooled chiller is nearly 5. But that 5 and the 2 extra benefit of 2 COP, we are killing with the cooling tower, and the water is scarcity in Johannesburg and as such in South Africa. So I'm with you 100%.
Yeah.
We have to look for the new technology.
Can I observe on that? So the COP, or coefficient of performance, as you refer to, you talk about 3 versus 5. I mean, that couldn't be further from reality. The reality is that COP changes every minute of every day. In the morning it could be 10, in the afternoon it could be 3. So you have to be careful of generalizing like that. Yes, of course, if you're using a water-cooled system, it would tend to be much more efficient, but you've got to be careful of saying that. COP changes every minute on any system. Yeah, thanks.
That, yeah. I think, yeah, those are really lively discussions. I think from what we've shared this part of the morning, it really goes to show for those that are industry, the resources that are available for you to get you started on the journey. It could be you just want to initiate an energy management system, you know where to call on. If you already know that you've got significant thermal loads in your facility, we have experts that have been working on these systems for quite a while that can impart some opportunities for you to improve your system. And of course, if you're now matured in your sustainability journey and you want to now start looking at alternative low carbon energy sources, the Energy Center is there to get you started on your renewable energy projects. So I would like to think the CSIR, specifically the NCPC and the Energy Center, is a one-stop show, really, if you want to get all questions answered around how do I get started on energy efficiency, on energy management, and renewable energy. So I hope the session was quite informative for you. You may need time to just go and marinate on what has been shared today, and you'll have questions later. Remember, at the back, the NCPC staff members are there to answer any further questions that you have. I think both Lawrence and Kevin will be here for the rest of the day, in case, you want to chat to them more. But in case you don't get a chance to talk to them today, just talk to any of the NCPC members and say, please help me get in touch with either Lawrence or Kevin, and we work with them. We will get you in touch with them. And of course, Faith and I are here today and forever. Okay. Last announcement before we break for lunch. Just a reminder for those who want to just get a of fan system. We've got a demo rig at the back, so as you nibble on your lunch, just take a walk there and let us show you what can be achieved on fan system optimization. And with that, thank you so much for your attention. Enjoy the rest of the sessions. Thank you.